Hello friends, welcome back to Flux Electrical Engineering YouTube channel. If you're new here, hit the subscription button so that you be notified whenever I post important tutorial like this. Today, we're going to explore one of the most fascinating and crucial components of our modern electrical infrastructure. The transformer. Electric energy is generated from generating station. This energy may not be sufficient to serve many consumers and those living at far distances from generating station. This becomes a challenge. The questions now become: 1. How can we boost this energy to meet up the energy demand? 2. How possible can this energy transfer to such far distance, with few energy losses? 3. If this energy reaches consumer's point, how can the voltage level be stepped down, so it will be useful for domestic and industrial uses without damaging the appliances and equipment? Because of these limitations, electrical machine called transformer is invited to solve the problem. But how does transformer do this magic? Stay tuned, because by the end of this video, you'll never look at power lines the same way again. Let's get started. First, it is important to know what transformer is. What actually transformer is? Transformer is a static alternating current device that step up or step down voltage levels without changing the frequency of the source. How does transformer transforms this voltage levels? Transformer has two coils of wire, mount on top of each other, known as the primary coil and the secondary coil. When an alternating current flows through the primary coil, it creates alternating magnetic field. This alternating magnetic field then passes through the secondary coil, inducing a voltage in it. This behavior of transformer primary winding inducing EMF to the secondary winding is called mutual induction. Depending on the turns of wire in each coil, the voltage induced can either be stepped up or stepped down. Note that transformers do not transform DC source. As you have understood how transformer works, there are important questions from our last statement. 1. Why does number of turns in a coil affects voltage transformation? Let's be practical here. Please, before I proceed, I will like you to use the link in the description box below to watch my video on inductor to understand this very well. Transformer secondary and primary coils are just like two set of inductors, in which one receives energy from other, through electromagnetic induction. When number of turns increases, the magnetic field flux produced will be higher than before, and strength of such magnetic field will be increased as well. This increased magnetic field flux will induce higher voltage to the neighboring coil closer to it. This is why we see in ideal transformer equation that EMF induced is proportional to the number of turns, and we can see now. 2. How can we know if transformer is step up or step down? Before I continue, step up transformer means that secondary voltage level is higher than primary side, and step down means that secondary voltage level is lower than primary side. Know that the primary winding is the input, and secondary winding is the output, or load side. For step-down transformers, looking at step-down transformer coils carefully, it will be noticed that number of windings in the secondary winding of the transformer is lower than primary winding. For step-up transformers, you will notice that number of windings in the secondary winding of the transformer is higher than the primary winding. Another way to determine whether a transformer is step up or step down, simply compare the turns ratio. The turns ratio, N, is the ratio of the number of turns in the primary coil, NP, to the number of turns in the secondary coil, NS. Mathematically, N equals to NP divided by NS. Let's use example. Suppose we have a transformer with 100 turns in the primary coil and 500 turns in the secondary coil. N equals Np divided by N, S, equals 100 divided by 500. This gives N equals 0.2. Since N less than 1, this is a step-down transformer. Summarily, if N greater than 1, it means step-up transformer. If N less than 1, it means step-down transformer. What happened if N equals 1? It means no transformation. Such transformers are used as insulation transformers. As you have understood how transformer works, it is important to know some key points about transformer. Things that don't change when a transformer is transforming. 1. Frequency of the AC voltage. The frequency remains constant, example, 50 Hz or 60 Hz, regardless of voltage change. 2. Power conservation. In an ideal transformer, the power is conserved. Power in the primary equals power out in the secondary. 3. Type of current. The transformer works with alternating current, AC. It doesn't change the type of current passing through them after transformation. 4. Circuits. Transformer makes use of electrical circuit for creating linkage magnetic flux, and magnetic circuit for inducing EMF to the secondary winding. 5. Basic components. The basic structure, primary coil, secondary coil, and core, remains the same, only their operational states change. Things that change when a transformer is transforming. 1. Voltage level. The voltage can either be stepped up or stepped down. 2. Current level. When the voltage is transformed, the current changes inversely. 3. Turns ratio. The number of turns in the primary coil compared to the secondary coil dictates how much the voltage changes. 4. Load conditions. The output voltage and current can vary based on the load connected to the secondary coil. Transformers are fantastic tools that help ensure electricity can be used safely and efficiently at various levels. Thanks for watching. If you have any questions, please leave them in the comments below. Don't forget to like and subscribe for more educational content. Have a nice day. Bye for now.